When we work with vectors, an important set of skills is, if we are given a complete vector, we want to be able to find its two vector components. So in this example, we have a velocity of 340 kilometers per hour north 40 degrees west. I'll rewrite that up here as a reminder. We want to find the x and y components of this vector. Always start by drawing a component triangle. So the direction of this vector is described as north 40 degrees west. So the first component that we're going to draw is the one pointing north. Remember, always draw the components with a dashed line. Next, we measure 40 degrees toward the west. Since this is less than 45 degrees, the x component that we're about to draw is going to be smaller than the y component. Always make this clear. Now we can draw the resultant vector. And here's the 40-degree angle that we were given. Let's label the three sides. Now that we have a good component triangle, we're ready to do our triangle math. Something that's very helpful, when you draw the component triangle, always draw it showing the given angle. We could have drawn a different component triangle, starting with the x component that has a 50-degree angle in it. But that just gives us one more opportunity to make a simple mistake. Okay, let's find the components. We'll begin with the x component. So when we set up this expression, we're not going to write out the trigonometry as we normally see it in math class. So this is what you do not need to write. For this side of the triangle, this is the opposite side relative to this angle, and that tells us that we're going to use the sine function. So you've learned before in math class, the sine of an angle is equal to the opposite over the hypotenuse. We're never going to write that because we'll get into the habit of doing this. If we want to solve for the size of the opposite side, we multiply both sides of the equation by the hypotenuse. This divides to 1. So whenever we want to find the length of a side, we always take the hypotenuse and multiply it by the appropriate trig function. This is the habit that you should remember. So, for the x direction, so this is the opposite side, the O, and it's going to be equal to, so we have the hypotenuse. The length of the hypotenuse is just the vector v. When we write it without the vector arrow over top, we always mean just the number part, just the magnitude. And then we have the sine of the angle. The angle is 40 degrees. Now we know from our physics understanding and our choice of coordinate system that this component needs to be negative. So we put in the negative according to our choice of the coordinate system. We don't use the cast system for our trigonometry work for our vector components in physics class because we want to be free to choose our positive and negative directions however we like. So for that reason, these angles are always going to be positive, and if we need to have a negative value for a component, we have to write it out in the front. That comes from our understanding of the situation based on our choice of the sign convention for the coordinate system. Okay, so we have that set up. We can do the substitutions. Always use brackets for the quantity that you're substituting. Always write down the units. Now it's time to use the calculator. 340 times the sine of 40 degrees. Notice I'm not putting the negative sign into the calculator because I know the result needs to be negative. Negative 218.5. Cut it off at 4 significant digits, kilometers per hour. So there's our x component. Now let's find the y component. I'll do the work over here. Let's look at our component triangle. Relative to this angle, the y component side is the adjacent side. So we know that we'll be using the cosine function. We're going to jump ahead to a step that looks like this. So we'll find Vy by taking the magnitude of V and multiplying it by the cosine of our angle. And multiplying by the cosine of the angle 40 degrees. This is in the positive y direction, so we don't need to include a negative sign. Time to substitute. It's always helpful if the substituted quantity is put into brackets. So 340 kilometers per hour multiplied by the cosine of 40 degrees. So we have a result of 260.4 kilometers per hour. So we started with the original vector, we drew its component triangle, and then we used our triangle math to find its x and its y components. Our angles are always positive quantities, so we have to show, or we have to put in, the minus signs if we know a component is in the negative direction of our coordinate system.